Question 17. Two charged particles P1 and P2 are launched in quick succession from O into a uniform electric field with the same velocity in a direction perpendicular to the electric field. Under the influence of the electric field, P1 and P2 are noticed to impact on B and C respectively, where AB equals to BC. The ratio of the magnitude of the charges on P1 and P2 is 3 to 1. In this case, the ratio of the masses of P1 and P2 is which of the following? Let's use the schematic diagram to visualize the problem. The two particles are initially at a height, say h, from the bottom. After being launched, they are both dragged by the electric field and hit the bottom. Given that particle 2 traveled 2 times the distance traveled by the particle 1, and the charge of the particle 1 is 3 times the charge of particle 2, we are asked to evaluate the mass ratio of particle 1 to particle 2. For convenience, I will let the charge of particle 2 be Q and that of particle 1 be 3Q. With this, we can write down the forces experienced by these two charged particles in an electric field E. Then, we can find out their respective accelerations by making use Newton's second law. Next, we denote the time for particle 1 and 2 to hit the bottom to be T1 and T2 respectively. Also, for convenience purpose again, we let the distance AB be x and AC be 2x. With this, by knowing that the launching velocity v of both two particles is the same, we can write down T1 as x over v and T2 as 2x over v. Now, since we have both the vertical accelerations, the times, and also we know that their vertical displacement h are the same, we are able to relate the two particles using the formula displacement equals to initial velocity multiplies time traveled plus half acceleration multiplies time squared. Furthermore, the initial vertical velocities of both particles are 0, so we only need to deal with the second term. By equating the expression of their vertical displacement, we can get the equation A1T1 equals to A2T2. The next thing we need to do is to sub in the value of acceleration and time we have obtained previously. Then with some simple computation, we can get the mass ratio to be 3 to 4. So, the answer is D.